Good day to you. This is teacher Leland Alejandro, and we are going to do solution of right triangles today. We're going to solve for sides and angles in a right triangle, and we will be using trigonometry. This is still under geometry. So let us start and see our problem sets. Okay, let's start with the first number. Okay, here's the right triangle, the given right triangle, and the instruction is there. Solve each triangle, round answers to the nearest tenth. All right, you can check on the given. You have angle A given, that's 65 degrees. And this is supposed to be side B. This is side B. You can see this is angle B and it's opposite side there. Opposite side. So that should be the side B. And sides are usually small letters, and capital letters are angles. So we can actually make use of the given. All right, we can start with the solution. Right, let's start. We can use the text. Okay, so it could be appearing much better than my handwriting. All right, let's start with what we have given. Okay. Given, we have their angle A. The capital letter is for angle, and this is 65 degrees. What else do we have? We will call that side B, and that is equal to 14.8 units. Okay, so we can make use of the parts of this, right? And we should check on the required. All right, we're asked to find the side A, and we shall denote it with a small letter. Okay, and that will be like this one. Find A, and also find C. Okay, you can see the small letters. All right, so find A, we're looking for this side. Now, A is supposed to be opposite the angle A, and we can also call it BC. There, BC. That's the same as side A, small letter A. Also, the side C, which is the hypotenuse, is the side AB. There, it's like this. Okay, so we have one more given actually. Let's put it here. This is the given right angle. Okay, so that can be considered given. That's 90 degrees. So we have 50% of the parts. Okay, we have two angles and one side. We're asked to get two sides and third angle. Okay, and so we can actually start solving for the angle B. Okay, and we can write this in the requirement like that. There. Okay, so these are all unknown. These are all unknown. There. Okay. All right. So we have the givens. We have the required. All right. So we shall determine what formula we're going to use to find those unknowns. Okay. We have here the opposite side and adjacent side if we're considering angle A. So we can use tangent. Okay. We can use tangent. And our working equation will be like this. Tangent of 65, the angle A, okay, that should be equal to A, side A, right, divided by the adjacent side, which is the 14.8. There. Okay, you can very well see that. The unknown small a side is the BC, capital BC, okay, divided by 14.8. The adjacent is equal to the tangent of angle A, which is 65. So it's A over 14.8 is tangent 65. So we can rearrange this by algebraic manipulation. This will be like A is equal to 14.8 multiplied by the tangent of 65, like this. And so we shall compute this. That means we have to get the tangent of 65 from our calculator. Okay, we can check on the value of the calculator. All right, let us check on the value of tangent 65. All right, you can use a calculator for this. Okay, so I will just show you the value after using my calculator. This means times tangent of 65, and we're going to use this. Okay, the calculator. Now make sure you have a calculator beside you and compute for tangent of 65. Yeah, and the value of tangent 65, 2.144, okay, 506921. Yeah. So that means that value will be multiplied by the 14.8, and we have the answer after that. So this is times 14.8 there. And we have the answer, side A or equal to BC there. BC is just another name for side A. Okay, so they are both names of the same side. Okay, the opposite side of the angle A. And the answer is supposed to be 31.7. Okay, and it says there we're supposed to round answers to the nearest tenth. Okay, so this is 31.738. It's supposed to be like this, 3870242 there. Okay, up to several digits after the decimal point, and that goes to our side small a. All right. Now we're going to solve now for our hypotenuse. Okay, our hypotenuse is the small c. Okay, small c, and this is also having another name, capital AB, based on the vertices of the triangle there. All right. Now the appropriate formula for this, we may use the cosine. Okay, to solve for c, and what we're going to do is to solve for c. Okay, to solve for c, okay, we can use the cosine function, and it looks like this. Cosine of, let's write the formula first. Cosine of A is equal to side. We shall be able to be familiar with the small letters. It's the side small b, okay, divided by the side c there. And b, of course, is 14.8. Okay, that's 14.8, and we can see that in the given there. It's over there. All right. Now we shall substitute now the values that we have. So it's b over c cosine 65. So this must be cosine of 65 there, and this is equal to b is 14.8, and we're dividing this by the unknown c there. So by algebra, the small c is equal to 14.8 divided by cosine of 65 there. So we have the numbers now on the right side of the equation, and we will just compute this. Okay, now I will write it in detail. So c is equal to 14.8 divided by, all right, we shall be able to get cosine 65 from our calculator. So that will be cosine of 65. So you have to know how to use your calculator. All right, of course. So that's cosine 65, and the value is 0.4226182617. There. That's from the calculator, of course. And so we will just divide this. Okay, we'll just be dividing 14.8 by the value. There. And we have something like 35 And here's the answer. So this is 35.01978343. Yeah. Okay, this is now the hypotenuse. Okay, so this is actually the hypotenuse. Yeah, that's the hypotenuse. Okay, we still have to compute for one more, the third angle. Okay, the third angle, and we know for a triangle, the right triangle, the two acute angles is a total of 90. Is a total of 90. The two acute angles, that means the A and the B, is a total of 90. So we can solve for B. Okay, so we shall try to solve it over here. Okay, let's put there for B. Capital letter means angle. Okay, so for B, this is how to solve it. A plus B must be equal to 90. There. This is only true in a right triangle. In a right triangle. So we can now use this to solve for angle B. And we have angle A 65, which is plus B, equal to 90. There. And we have here B is equal to 90 minus the 65. There. And this must be about 25. Okay. 25 degrees. Okay. All right. Okay. All right. Now this is our computation, and we shall be able to check our answers. All right. We shall be able to check our answers. Now we're supposed to round our answers. Okay. Let's check on our answers. Our side A is supposed to be like 31.7, rounded. Okay. Our side C, the hypotenuse, is 35.0. 35.0. And of course, our angle B is 25 degrees exactly. All right, we can verify the answer. We shall be able to verify the answer there. Okay. All right. So there in the diagram, you can see the red numbers, and those are the answers, the correct answers. And we got them all correct here. 31.7 for the opposite side of angle A. Angle B is 25, you can see it there. And of course, the hypotenuse is 35. So at least we are correct with the first number. Okay, let's continue with the next. I hope you were able to learn from these computations, and this is how to solve right triangles. Okay, so I will just erase this and move to the second number. All right, let's next example. Okay, again, solve each triangle, round answers to the nearest tenth. Okay, let's have number 2. Okay, here's number 2. All right, let's start with the given. Start with the given. We have, all right, what do we have here? Angle A is unknown. Okay, angle A is unknown. Angle B is unknown. Okay, angle A is unknown, angle B is unknown. So we can also check on the given. We have angle C, 90. It's a right triangle. Also, we have, this is 7. That's opposite angle A. So this must be the small a. This must be the small a. And the other name for this is BC. There, using the vertices of the triangle, BC. So this is equal to 7. Also, we have small b. That's the side opposite to angle B. Small b is 2. So we can put it here. All right, let's put one more there. This is small b, and this is also called AC. Capital letter A, capital letter C. And this is 2 there. All right, so we have this given data. Let's write the requirement. Okay, we're asked to find, okay, side C, small letter side C, or better known as AB. Okay, there. Those are two names of the same side. Okay, all right. So what else? We're asked to solve for side C, the hypotenuse, and we're asked to get angle A. There. Also the other angle B. There. Okay, so we shall try to make use of the two sides because we don't have two angles. We only have one angle, but we have two sides. So we can make use of Pythagorean theorem here. Pythagorean theorem. So to start with, we can immediately solve for side C. Okay, and the Pythagorean theorem is like this: small c squared is equal to a squared plus b squared, and then the sum of that square root. Okay, and this is how to write the equivalent. Okay, we shall write side A and then raised to the power 2. Okay, raised to the power 2 plus we can get the side B raised to the power 2 also. That means squared. Okay, squared, and then we're going to enclose this like that, and then this will be raised to the power 1/2. Okay, or 0.5. That means square root. Okay, square root. Now you can also write this in another way. Okay, you can also write this in another way. You can use this. Let me see if my pointer works today. And you may write this a squared, and this is plus b squared, like that. Okay, and this is supposed to be equal to c, the small c. There, that's the Pythagorean theorem. Now the square root symbol, that means raised to 0.5. Okay, raised to 1/2. And so we will do the substitution of the values. Okay, we shall write here small c is equal to the, okay, value 7. Okay, 7 raised to the power 2. That means squared, plus we will get now the b, which is 2 raised to the power 2 squared. Okay, and so this will now be square root, that means raised to the power 0.5 there. So this shall give us 49. That means 7 times 7, that's 49. And we have 2 raised to 2, that's 2 times 2, which is just 4 there. And this will have to be extracted. Okay, extract square root of 49 plus 4, and that will be square root of 53. And this will be square root of 53. 49 plus 4. So that will be square root of 53 there. And so we can extract the square root of 53. Okay, we use the calculator. That will be square root of 53. That's equivalent to 7.28. 7.28. I will write all the digits and we will round later. 0.9889. There. That's the value of the hypotenuse. This is the hypotenuse. This is hypotenuse. That's the value of the hypotenuse there. All right, so we can now determine the angles. We shall try to determine the angles now. And we have to start with, say, angle A. So this is tangent angle A is equal to A over B. There. This is the formula. Tangent of angle A is equal to side A over B. So side A is 7, side B is 2. And this will continue like 7 divided by 2 there. And so we're going to get the inverse tangent. Inverse tangent, that means you're going to determine the angle. Okay, you're going to determine the angle. So you will have to write it this way. Angle A is equal to arc tangent of 3.5. That's 7 over 2. There. And so angle A is equal to arc tangent of 3.5. You will have to use the calculator here again. All right. So I suppose you know how to use your scientific calculator when doing this. Okay. So this will be inverse tangent of 3.5. That should be 74 degrees. So this is 74.0546041. And this is in degrees there. Okay, so that will be for our angle A. Now we can compute for angle B by using the ordinary formula. We can now use the ordinary formula. We know that the total is always 90. So we can use A, all right, plus B equals 90. And this is only true in a right triangle, okay? In a right triangle. And it's got to be both acute angles, the A and B. All right, so we have the value of A, that's 74.0546041. And we will add the unknown B, and this must be equal to 90. Okay, and this is only B equal to 90 minus 74.0546041. There. So we'll just get the difference and we will get the value of B. There. Okay, so this will just be minus, and we have the answer. It's 15.9. 453959. There. This is also in degrees. There. So we have all the required answers now. Okay, we can summarize it below. All right, we have side C. We're supposed to get the rounded value. So rounding this to nearest tenth, this must be about 7.3. 7.3, like that. Okay, and our angle A, this must be like 74.1. 74.1. That's angle A there. This is in degrees, of course. This is in degrees there. And we now have angle B rounded to the nearest tenth. That must be exactly 16. We can still write it 15.9 or 16, okay? 15.9 degrees. 15.9, very close to 16, okay? Very close to 16. All right, let's verify the answer and check it out. Okay, so we have here 7.3, the hypotenuse C. We have 74.1 degrees and 15.9. Exactly what we have on the board, okay? All right, so this will be the way to determine unknowns in a right triangle. Shall we have one more? All right, let's clear the board and go to the next problem. All right, let's clear. Okay, and let's remove the answers. Proceed to the third. All right. Okay, here's the third right triangle. Solve triangle, round answers to the nearest tenth. All right, what do we have here? All right, let's start with the given. Start with the given. We have angle A, capital A is an angle, and it's equal to 40 degrees. All right, I'll just abbreviate it. And what else? Opposite angle A is the side A. So we will call this small a, okay? We'll call this small a. And this is 8.1 units. It's a unit of length, okay? Unit of length. It can be in meters, feet, okay, yards, okay? All right, so what else do we have? We have that mark there, okay? We have that mark. That means angle C is a 90 degrees. So capital C equal to 90 degrees. Yeah. So we have a right triangle, a right triangle. All right, so you have two angles. There are only three angles in a triangle. We can solve immediately the third, okay? We can immediately solve for the third angle. But before that, let's write the requirement. Let's write the requirement first. Let's put it over here. Okay, we're supposed to find, okay, angle B. They're capitalized, so there. What else? We're supposed to find side B, the small b, side B. And we're looking also for side small c, the hypotenuse. There. Now, if you're not familiar with these small letters, big letters, we can use the vertices of the triangle. The side B, that's AC. There. If you're very familiar with geometric labels, it's like this. The side AC. What else? Side C hypotenuse is the AB. There. For those not familiar with trigonometric notation, okay. All right, there. All right, you can use the vertices of the triangle. All right, let's now solve, okay? All right, so let's start with angle B, okay? We have two angles, we can solve the third. So the formula will be, this is a right triangle, so we can use the A plus B equals 90. A plus B equals 90, okay? We're solving for angle B, okay? So B, there. We're solving for angle B. All right, so direct substitution. Direct substitution. We have capital A, the angle 40 degrees, plus the angle B is equal to 90, okay? Two given, one unknown. Angle B is just 90 minus the 40, there. 90 minus the 40 gives us 50 degrees. Okay, we have one, all right? We're done with angle B. So all angles are solved, okay? We will now attempt to solve the sides. All right, so what should be the appropriate formula? We can use here sine and tangent, okay? Sine and tangent. All right, let us make use of tangent first. Okay, we're solving for side B, okay? So solve side B, there. Okay, here's the formula. All right, tangent of angle A is small a over small b. There. It's opposite over adjacent. At this point, you must be familiar with the formulas for the trigonometric ratios. So this will now be tangent of 40. This is equal to 8.1. Okay, 8.1 divided by what you're solving, the small b. And then by algebra, okay, this is equal to the next line. B is equal to 8.1 divided by tangent 40. There. 8.1 divided by tangent 40. And so this will be equal to 8.1 divided by tangent 40. We can get the tangent 40 from the calculator. So we will compute for tangent of 40, and we have the value. Calculator value is 0.8390996312. There. And this will be the divisor there. Okay. So we shall just divide this. Okay. We will just divide. All right. So this is 8.1 divided by all right. We have 9.65. All right, let's continue and write the answer. This is small b. Computed value is 9.6532041. There. And this will be in units, okay? It's a unit of length, okay? All right. So there is no given unit of length like meters or feet. So we will just write there 9.6 units, okay? It's like that. So we are done with side B. We still have to compute for side C, the hypotenuse. So we shall try to get the answer from here. All right, let's do it over here. Okay, we're solving for C. Solve for C. It's a small c. That means it's a side. Or you can put there side C, like that. Okay. And you can now make use of the given. Take note, when solving parts, do not use computed value. Use the same given, 8.1 and the 40. Okay, 8.1 and the 40. So for now, we will be using the sine function because that involves the small c here and the small a and the angle A. And the formula for sine A, and that should be A over C there. And so we have here sine of 40, direct substitution, equal to small a, that's 8.1. Then we divide this by what we are solving there. And then after algebra, this must be equal to small c is equal to 8.1 divided by sine 40 there. Okay, I hope you know how to manipulate those parts of the equation. That's c equal to 8.1 divided by sine 40. And for the equivalent of this is also equal to 8.1 divided by the value of sine 40. Again, we will use the calculator to get the sine of 40. All right, there's the value, 0.64278,76097. Let me write it down. That means 642787 6097 6097 there. Okay, that will be the value of the sine 40. Let me extend this so it will be on the same line there. Okay, and then we shall now divide to get the answer. All right, so we have 8.1. We divide this by that value, and that gives us 12.6 for the hypotenuse, 12.601,363. There. Okay, so we're done. We're able to get all the answers. We have the two sides and third angle. All right, so angle B is 50 degrees. Side B is 9.65 and side C is 12.6. Now we shall write the rounded version somewhere. All right, let's put it over here. Let's put the rounded version over here. So let's start with the angle B. Angle B is 50 degrees. And then we computed side B. We're supposed to round it to the nearest 10. The 6 here will become, because it's after that, you have the 5. Okay, so that means when you round this becomes 7. So 9.7. Yeah, 9.7 units. And we have side C. round to the nearest 12.6. There. All right, we have all the required answers. Let's verify the answer. Okay. So we have 50 degrees for angle B. Okay, you can see the red numbers in the diagram. We have 50 degrees, we're correct. All right. And we have 9.7 for the required side B. Okay, side B, opposite the angle B. So this is side B there. And of course, our side C, opposite the right angle, it's over there, 12.6. All right. So we're done with the solution of the right triangle. I hope you were able to learn from these three examples. You can try doing your work. All right. And see you later. Bye-bye.